This one is going to be on foldr fusion law. I think this is the only video on YouTube that explains this law specifically. Yeah, so let's get to it. So the claim of this law is that if you take a function h and you compose it with a fold, and this thing is a new fold with a new function g with a new initial element b. Okay? So concretely, if we want to apply this to a list, because this one is point-free notation, let's say you have a list which is called x's, and you would say that this is the same as this. Okay? Now this is a claim, so let's actually prove this. Let's try and find out what properties G has and what's B. Okay? Okay, so there are basically two cases we need to go through. First case is an empty list. Case empty list. Okay, so let's draw a line here and see what this side here equals and what this side here equals. Let me move this one a little bit to the left. So let's rewrite it in a standard notation, pardon me. This one is going to be equal to this, which means that it equals h of e, because a fold of an empty list is the initial element. Okay? Now this one here to the right is going to be equal to b, because again, let me just write it in the same fashion. So a fold of an empty list, because we said it's the case for an empty list, equals the initial element. So what this tells us is that h e equals b. So let us rewrite this rule here. So we learn now that b, this one, is equal to h of e. Okay? Now let's explore the case where we have a non-empty list. Okay? And we said I'm going to rewrite this basically. It's h of fold fe x x's. And I don't remember if we need the parentheses here, but I'm gonna put them there. I'm not that familiar with Haskell yet. And here b now is h of e, and here we have our list. So let's draw a line and see where this is gonna lead us. So basically now we found out what b was. It's h of e. Now we're going to find what's g. So what's a fold? Basically, let's do a reminder here. What's a fold? Of a list. foldr of a list. What does it equal? What's the definition of a foldr? It is the application of f to x as a first parameter, and the second parameter is the fold of the rest of the list. Okay? Okay, so this means that this equals to f applied to the first element of the list as the first param, and the second param is going to be foldr fe of the rest of the list. All right. Now what does this one equal? This one is the application of g to the first element of the list, and then to the fold of the rest of the list. Okay. Now, thanks to induction, we know that this part here equals this thing here. So let's replace that expression. Okay. Now we notice actually that this part here is the same as this. So what does that tell us? Just like we did before for the empty list. It tells us that h of f x y must equal g gx of h and y. So this one is y, it is here, the h is here, and gx is here, and this one is y, goes here, the x is here, the f is here, and the y is here. Okay, so now let's rewrite our law completely. So we said that the composition of a function with a fold is a new fold where h f x y equals gx h y, and this is called the foldr fusion law. So now that we proved this law and we've extracted its properties, let us actually use it in a more practical context. So basically, this allows us to fuse computations. So instead of composing a function with a fold, we can basically do that in one step with only one fold. So let's do some concrete examples. Let's say double composed with sum. Okay. Now we know that sum is a fold, basically. This one is a fold. So we could use actually fusion law. Let's write it as a fold first, okay? Double. So sum is a fold with the function plus and the initial element 0. So how can we fuse this into a single fold? Now, according to the fusion law, this must equal a new fold with a new reducer or new fold function, and h of e. So h in this case is this guy here, and e is this one. Double of 0 is 0. Okay? So now we just gotta find g, our new reducer or our new fold function. So we're gonna find it thanks to this property here, okay? Now let's write this one down. So to find g, so basically h is double, okay? So this is h. F is this one, is the plus, and xy can be anything. And this should equal to g, x, and h is double, y. Okay. Now let's see what we can do with this. So double x plus y. This is the same as double x plus double y. Right? Which is equal to g x double y. So what I tend to do is just develop each or one of the sides of the equation and try to find similarities. Okay, so what I notice here is that this is the same as this. So what we can say about g, so g takes the parameter x, is a function that takes takes two params, x and y, and what it does to x is it doubles it, right, and adds it to the second parameter. Okay. Now in point 3 notation, we could say that gx is plus double of x. Or we could say that g equals double composed with plus. Now that we found our g, we can rewrite this guy here. So double composed with sum is a new fold with our function g, which we found here. With our initial element 0. Now let's do another example. Let's say we want to fuse a map double with a map of increment. Inc is just a function that increments an integer. Okay, so let's write this first, the second thing here. So this is going to be our h, and let's write this one as a fold. So map is just a fold. The function is going to be, we increment, then we concat. The initial element is going to be an empty list. Now this is our f. This is our e. And this is our h again. Now the fusion law says that this whole thing here is a new fold. Okay, we gotta find g, we're gonna find h of e. So what's map double? What's h of e basically? Let's write it. This one is the easy thing to find. What's map double of an empty list? Just an empty list. Alright, now we gotta find g. So what's g equal? So basically we saw earlier this thing here. Let's just write it down. Which means concretely, now h is this, so map double f is this one, the syntax is a bit unwieldy, so basically this goes like that, and this second part here is GA. H is map double of B. Alright, so we gotta find G. Let's develop this equation. Now, this one here means so inc of A is A plus 1 concatenated with B. Alright, this side is this. Now this side here can be written as double of A plus 1 concatenated with map double of B. And that's the definition of map, actually. Okay, so the goal again is just to find similarities. So we just found one. Is that this thing here is the same as this thing here. So now we can write our function g. Okay, so now we can rewrite. First we can write our function g. So this g here, what does it do? Takes two params, a and b. What does it do to a? Well, it increments a, because this one again is just inc a. Increments a, doubles it, and concats that with b. Let's simplify this into 0.3. So let's remove b first. That would mean that this would equal this. And this is, I think, what we call a section in Haskell. I'm not sure again about the parentheses. Maybe it's like this. And then let's try and remove a. So what we do with a is we increment it, double it, and with the result we concat. Alright, now that we found our g, we're gonna rewrite this thing here. So map double composed with map increment is a fold with this g here. And we said that our initial element was just an empty list. So basically, instead of traversing the list twice with two maps, we fused these two computations into one fold, which only traverses the list once. So that was the foldr fusion low. Hope you find this handy. Thanks for watching.